Hi dears, welcome to my channel. Today I am here with class 9, 8th lesson, force and first law of motion. What was the 7th lesson? It was motion only, right? It was motion. Then I have asked you 3 questions. It's the time to answer these questions. Okay, I am reading the question. A particle is moving a circular path with radius r. Okay ma. Displacement after half the circle is dash is the question. Displacement after half the circle will be what ma? If the radius is r, after half the circle it will be 2r, isn't it? 2r. Okay. Second one, 2r it can be again said as what? Diameter. Okay. Second one is slope of velocity time graph is dash. Slope of velocity time graph is what ma? Is acceleration. Okay. Then the third one is area under the velocity time graph represents the physical quantity having unit dash. Okay. Area under velocity time graph shows what? Area under velocity time graph shows displacement. And what is the unit of it? It is meter. So it is a tricky question and you have to read the question and understand that, then only you have to say the answer or write the answer. Okay ma? The question time is over. Now we are moving directly to the class. What is the class? Force and law of motion. For every object in the universe, we are applying some force for it to change its position, its motion and all. Okay. So what is force? Force is push and pull. In small classes we have learned push and pull. But push and pull only will not become the force. We are applying this push or pull with a particular mass. So that what happens? The objects will change its state. Means the object will change its state of rest or of motion when we are pushing or pulling the object. It is what ma? It is called force. Okay, is it clear? We are pushing and pulling with mass. That is force. Okay. Is it a vector quantity or a scalar quantity? What is a vector quantity or what is scalar quantity? The quantity which is having either magnitude or direction is a scalar, while the quantity which is having both the direction as well as the magnitude is called vector. So force is a vector quantity, which means what? Which means it's having both the magnitude as well as direction. Magnitude, how can we find out? Magnitude is to say the amount of the force which we are applying is the magnitude. Consider the case of bucket. When we are taking a bucket which is having half the bucket filled with water, we are taking it. So we are applying force or not? Yes, we are applying force to lift it up. But how much force we have to apply? We have to apply some force. Some force for it should be required for lifting the bucket. Okay, the force which is required for lifting the bucket, for that amount we are applying force. Okay, when the bucket is filled with water, is the force same as that we have taken for lifting half the bucket? No. Means the force should be much more greater than the initial one. So we can say force is having magnitude which varies with the mass. Okay, which can be varied with the mass. Okay, then not only magnitude, the force is having direction. Okay, how can we prove it? When your mother is pushing a table forward, you came and you saw that. So what you have done? You are supporting your mother. In the same position you are standing and you are pushing along with mother. Will it move here quickly or not? Yes. In which direction? In the direction which your mother is intending. If she want to move it to the left corner, it will be moving in the left corner. Isn't it? Okay. Instead, when your mother is pushing the table towards left, you came, no amma, it is not correct. It should be in the right only. And you are pushing the table from the opposite side. So what happens? The direction will not be the direction of your mother. The direction which your mother has been intended. Because you are pushing in some other direction. So, is the direction playing a role in the force? Yes, absolutely. This direction also plays a good role in force. Okay. Now we are moving to see the forces, types of forces that are frictional force. When a ball is rolling on the ground, okay, freely when it is rolling, after sometimes you can say the ball is stopped. The ball stopped its motion. Why? Because of the friction from the earth. Friction, it is exerting friction. When any body is moving freely, friction will be opposing. A frictional force is the one which opposes the motion and which opposes in the motion so that it will apply in opposite direction, which makes the body to be in rest. This is the frictional force. Frictional force plays a good role for you because if the friction is there only, the brakes can be put for vehicles. Otherwise, it will be going smoothly. It will not come to an end. It has to be come to an end, right? So that frictional force is playing a good role over there also. In many cases, this friction is applying. Then the second one is muscular force. As I told you, when you are lifting a bucket filled with water, you are applying which force, ma? You are applying muscular force. These forces are contact forces. Why I am saying that it is contact? Because this forces will be acting only when the body is in contact with it. When the body is in contact, only these forces are acting. So we are saying these forces are contact forces. So is there any force which will be applied without in contact? Yes, absolutely. Gravitational force. When an apple is just left the tree, it will be directly coming to earth. Why? The earth is moving there and putting it down? No. It is attracted by the earth and it will be coming down directly. Gravitational force. To say earth is revolving round the sun. In which force it is revolving round? By the gravitational pull of the sun, the earth is revolving. By the gravitational pull of the earth, the moon is revolving the earth. Like that, in the universe, this gravitational force can be seen. Okay. Second is magnetic force. Even though magnet is not in contact with the iron objects, wherever the magnet is, the iron will be coming in contact with it, right? Even though magnet is in a large distance, if the magnet is much more powerful, the things which are attracting towards the magnet come and stick over it, isn't it? Magnetic force is non-contact force. Like that, electrostatic force is the third one. It is also a non-contact force. Okay, even though this force need not be in touch with the objects for it to act. These forces are called what, ma? Non-contact force. So, how many forces are there? How many types of forces are there? 2 types, contact force and non-contact force, and the examples also we have seen. Okay, ma? Then, we are going to say about the balanced force. Okay, what is this balanced force? As I told you, your mother is pushing the table in one side and you are pushing it in opposite side. If you are much more stronger, what will happen? The table will move in the direction which you intended. And if your mother is stronger, the table will move along with your mother's intention. Or if both are stronger, if both are having same energy, what will happen? The table remains at rest. From that you are understanding balanced as well as unbalanced force. If the two forces which are acting, 2 or more forces are acting in equal and opposite direction, the net results will be 0. This is what, ma? Balanced force. Okay, this is balanced force. And if the 2 forces are acting and if the magnitude is greater or lesser, or there is much more comparison, what will happen? The objects will be in motion in direction of greater magnitude. Okay, that is what, ma? That is unbalanced force. A best example is tug of war. Tug of war is the best example. If both sides are much more stronger, the rope will be in balanced way, and if one side is stronger, it will be moving in the other direction. Okay, their direction only. They are pulling, right? So it will move in their direction only. Okay, thus balanced and unbalanced force is also clear for you. Now, with this balanced and unbalanced force, we are explaining Newton's law of motion. What are the... Okay, dears, the laws of motion. The first one is first law of motion. What is the first law? Every object remains its state of rest or of uniform motion in a straight line unless an unbalanced external force acts on it. When you are hearing Appa, it's so difficult. It's having a good example. You are the good example for that. When the day is Sunday, what will you do? You will be go on sleeping. Isn't it? You will be go on sleeping unless your mother came and shout at you. Right? When she is shouting at you, you will jump up. Yes, yes, I have to go. Like that you will go. Yes or no? The same thing that Newton has been proposed. He proposed the same thing. Every object continues its state of rest. The same, you continues to be in rest or in uniform motion in a straight line. If the body is in moving, it will be continuously to be in motion. Unless an external force, who is the external force here? Your mother's shout, right? External unbalanced force is acting on it. Unless your mother is going on shouting with you, you will be going on resting. Till it is afternoon, you will be taking rest, right? This is what Newton's first law. Everybody is having the tendency to be in rest, if it is in rest. Or everybody is having the state to be in motion in a straight line if it is moving. But if an external force and that external force is unbalanced, that's why balanced and unbalanced force I have taught you. Okay, if the balanced force is coming, it will be nullified and the net result will be 0. But if an unbalanced external force is pushing it, what will happen? It will change its state. Now is it clear for you? Okay, this is what I am saying. This is Newton's first law. Can we see some examples? If I am saying some examples, it will be clear for you. Okay. The thing is, first one, when we are seeing a tree with full of mangoes, what will you do? One mango I want to have. So, what will you do? You will take a stone and kick, right? Okay. So, when you are throwing the stone over the mango, what will happen? The mango will fall down. Yes or no? If you are a good aimer. Otherwise, the stone itself will fall on your head. That's the other thing. But otherwise, when you are throwing the stone correctly on the mango, it will fall down. Why? Because the mango was in rest. Now also, the mango want to remain in rest. But what happens? An external force, what is that? The stone with a force is kicking it. So what happens? It is not wanting to change its position or change itself with this force. So what happens? It will be plucked off from the tree and it will come down. Okay? Okay. Then, so what we are saying is, everybody want to be at rest or uniform motion. They resist external force. They don't want to move from this place or they don't want to change itself. Unless a force is applied, it will be always in rest or in uniform motion. When you can say, when you are in bus and you are in the inside the bus and you are standing, okay, when the bus was in rest and when the bus has started, what happened? You will quickly lean back. You will lean back side, right? When the bus has been starting, isn't it? Why? When from the rest, motion has been started. So your legs is already in motion with the bus. But what about the body part? The body part want to be in rest. When he is taking the bus itself, what happens? The body want to be in rest, but it is in motion. So we are leaning backside. Similarly, in a moving bus, when the driver is putting brake, what happens? We will push forward, right? Have you ever thought why? The reason is this only. Your body was in uniform motion. Your legs are in touch with the bus and when the bus comes to a sudden break, your legs will be always with the bus and it stops. But your body part is still in motion. It does not want to be in rest. So what happened? It is leaning forward. Okay, this is law of inertia. Everybody resists the change which is happening to it. That's what it is the law of inertia. It is also along with what first law, Newton's first law of motion. Is it clear? Okay. Then we can say when you are inside a car and when the car is in still motion and you are moving along with the car, when a turn came, a sudden turn came and the car is in the turn, what will happen? You will move to the opposite side. Yes or no? You will move to the opposite side. It's also the part of inertia. So inertia can be of three types. Inertia at rest, inertia in motion, and inertia of direction. Inertia at rest was what the mango and the stone. Inertia in motion was what when the bus driver is putting sudden brake. It will be your body want to be in motion, but it is coming to a sudden rest. Okay. Then inertia of direction is what in the turns when the car or any vehicle is turning, your body is also moving in the opposite direction. It is moving to the sides. Okay. This is inertia of direction. So these are the things which you are understanding from the first law. What is that? Everybody want to be in rest or uniform motion unless an external force is acting on it. Okay. Is it clear? Second law is continuation of the first law. What they are saying is rate of change of momentum is directly proportional to force. Don't be afraid of. Nothing is there. Okay, consider a ball. Okay, a ball. When a cricket match is going to happen, our cricket match is happening and a bowler is bowling. So he is bowling. So a ball is moving. Ball is moving in. A ball is having mass or not? Mass is there for the ball? Yes, a small mass is there. And when it is in motion, it will be having a velocity. Yes or no? Velocity is there for the ball. So, in a more mass and with a particular velocity, a ball is moving. What is the batsman doing? Is he just seeing how the ball, how beautifully the ball is moving? No. What is he doing? He will kick. Yes or no? He will kick it with the bat. So, what happens? When he is kicking, he is applying what? He is applying force, not just force, external unbalanced force. So what happened? The first law, as I told you, it was in rest, or it was in uniform motion in a straight line, but an external unbalanced force is applied. So what happened? There will be change in the direction of the ball. Not only that, the speed also changes, yes or no? Speed of the ball changes or not? Yes. The ball got high speed and it is moving in a particular direction. Yes or no? So, is there any change in the mass for the ball? Mass is not changing. The ball is having the same weight. That weight is itself for the ball. Mass is not changing. But the velocity is changing. Velocity is changing. It was initially in one velocity. But after some times when he is kicking with the bat, the velocity changes. Or velocity will be increased. Yes. Velocity will be much more increased. Okay, so there will be a certain change. So to say 30 meter per second was the initial velocity. Just I am saying 30 meter per second was the initial velocity of the ball. When he is kicking with the bat, it changes into 70 meter per second. Okay, quickly will it change to 70? No. 30 will change to 40, then 45, 50, 55, 60, 65, 70. Then only it will reach up to 70. Yes or no? Okay, so momentum, what is momentum? Mass into velocity is the momentum. As I told you, initially the ball was coming, one mass is there and one velocity is there. So I calculated mass into velocity, I got one momentum. Okay, when he is kicking with the bat, it changes up to 70 meter per second. So what will be the final momentum? Same mass with changed velocity is the final momentum. So change of momentum is happening, but it needs some time, right? Quickly will it change? No. Within seconds, it will be fraction of seconds or something, but time is needed or not? Time is needed, and with the time it is changing. So, as we are comparing it with the time, it is the rate of change of momentum. This rate of change of momentum is proportional to what they are saying. It is proportional to external applied force. Yes. Only when the force is applied, momentum changed. And momentum is changed along with the time. So, rate of change of momentum is proportional to what? All because of this batting person, right? He kicked with the bat. Then only all these things has happened. Yes or no? So, external applied force, because of this force, momentum changed. This is the second law, so easy. What is that? Rate of change of momentum is directly proportional to the applied force. Okay. So, what you are understanding from that? Mass is not changing, but the velocity is changing from initially to finally. Change of velocity with time is what, ma? When velocity varies with time, what will we say it as? It is called acceleration, yes or no? Change of distance or displacement gives you velocity, and change of velocity, rate of change of velocity, that is change of velocity with time gives you what, ma? Acceleration. So, what is the force equal to? Force is equal to the mass into acceleration. Is it clear, Kanna? When we are applying force, acceleration will be caused to the objects. Mass into acceleration gives you what, ma? Force. It is equal to force. In 8th standard, you have learned what is the unit of force. It is Newton. Okay. But much more in depth you are not able to understand, or you didn't study. But now there is an explanation for the force. Force is equal to what? Mass of the object into its acceleration. Okay. So, what is 1 Newton? What is SI unit of force? It's Newton. So, what is 1 Newton? When an applied force acts on the body of mass 1 kilogram and which causes a change in acceleration of 1 meter per second square, we can say the force is 1 Newton. 1 Newton is applied on it. Okay. So, SI unit of force is Newton. What is the CGS unit of force? CGS unit of force is what, ma? It is dyne. D-Y-N-E. This D should not be capital. D should be small letter. D-Y-N-E. Dyne. Dyne is the CGS unit of force. And the SI unit of force is Newton. Is it clear about the second law? Okay. We can say a good example as this batting, the cricket. Or sometimes if someone is walking, dogs are coming and barking towards us, what will happen? We will get speed. So, what happens? The mass of your body is the same, but the velocity changes, right? Yes or no? You will be running, right? Seeing the barking dog coming towards you, you will be running. So, velocity changes. So, what? The force. Then only we can say, with the full force I ran and I am so tired. You will say, right? Because the force you are applying over there. In many cases, you can see, when only the force is applied, the changes can be happened. Okay? Okay. Now, the third law. Third law is very easy, dear. What they are saying? For every action, there will be equal and opposite reaction. Okay? Whatever you are doing, you will get its result. Yes or no? That's why you should be careful, right? If you are doing good things, you will get good results. If you are doing some evil things, like in TV serials, many villain characters, are there. They are doing some evil things and things. Finally, they are getting their results, right? All these can be seen in television serials or in films and all. Like that, for every action, God is watching you, right? For every action, there will be equal and opposite reaction. If you are studying only, you will get good marks. If you are not studying and fully playing, the marks also will be 0. Okay, like that. How can we apply over here in physics? We are going in some other way. Okay, how can it be applied in physics? See, as I told you, for every action, there will be equal and opposite reaction. But this action and reaction occurs in same object. Yeah, no. Why? Because if it is action and reaction is occurring in same objects, it will be balanced and the object will not move. Action and reaction are applied in different objects. Okay. Okay. See, to say, if you are swimming, with the two hands, you are pushing the water backwards. Yes or no? With the hands, you are pushing the water backwards, and with full energy, the water is pushing you forward. Then only you are able to move while you are swimming. Okay. And the same thing when we are shooting a gun with a gun. The gun is applying force on the bullet, and the bullet is applying some force back towards the gun, which results in the recoiling of the gun. When we are shooting, what happens after when the bullet is going, the gun will be moving backward. Have you ever noticed? If the gun will be moving backward, this is recoiling of the gun. Okay. Then when we are jumping, or somewhere, if boat is there, if you are inside the boat and you are jumping towards the to say water or in the land from the boat, what we are doing? We are applying force. Your feet is applying force on this boat, then only you are jumping, and the boat is applying force over you, which makes you to be in the air. Okay. Trampoline is the best example. You are applying force. How much force you are applying down, that much force you are moving forward. Yes or no? Trampoline, everyone is enjoying and seeing this trampoline. Okay, isn't it? You are applying force, much more force when you are applying downwards. To that extent, it will be making you to jump upward. Okay, or to say bouncing ball. The same thing is happening to the bouncing ball. All these we are saying what? Equal and opposite reactions can be seen. This is the Newton's third law. Dears, now the last topic is conservation of momentum. What they are saying? The momentum is neither created nor destroyed. Okay, that means momentum is conserved all the time. So, how can we say that momentum is conserved? It can be said with the help of two balls of mass, different masses, m1 and m2. When they are allowed to roll, okay, what happens? They will move in a particular velocities, isn't it? Let initial velocity of m1 ball or the bigger ball be u1 and the smaller ball be u2. Okay, they are moving in a straight line. At one point, what happens? They collide each other. What they are doing? They are colliding. Is there any external force acting on it? No. No external force is acting. It is moving by themselves and they are colliding. And when they collided, what happens? Velocities will be changed. But the mass will not change, as I told you, right? Mass will not be changed because the ball will be ball only. But the velocities will be changed. Then the velocity of the bigger ball will be changed from u1 to v1. And smaller ball changes from u2 to v2. So we are going to see how the momentum is conserved. Okay. By applying second law, we are seeing. Okay, ma. Ball A, when they are colliding, the collision lasts for a particular time t. Okay. So what happens? We can say the force is applied because when the ball A is collided with ball B, a particular force will be acting on it, isn't it? So rate of change of momentum is directly proportional to what, ma? Force applied. So we are going to check how much force it has been applied. Okay. Ball A exerts force AB on ball B. See, ma, two balls, ma, when they are colliding at a particular time interval t, then the ball are changing its velocities. We are seeing ball A exerts force AB on ball B. Similarly, ball B exerts a force BA on ball A. Okay. Now we are going to see what, ma? Rate of change of momentum. Rate of change of momentum of A due to BA is what, ma? It is FBA is equal to MA, okay, into VA, that is final velocity of ball A, minus mass of ball A into initial velocity MA UA divided by T, that is particular time T. Okay, ma? then the rate of change of momentum of B due to FAB is what? It is equal to mb Vb, that is mass and final velocity of ball B minus mass and initial velocity of ball B divided by T. Okay, what is the Newton's law saying? For every action, equal and opposite reaction. So, FAB is equal to minus FBA. Equal, but the reaction is opposite, no, direction is opposite. So, what is FAB? It is equal to minus FBA. So, MBVB minus MBUB divided by T is equal to negative value of MAVA minus MAUA divided by T. So what happens? T cancels each other and the negative will go inside and A part will come in one side and the B part will go in that side. Then from that we can find the final answer as MAUA plus MBUB is equal to MAVA plus MBVB. This is what we have to prove. So what we are understanding? The initial velocities and mass together will be equal to final velocities as well as mass. So what we are saying? The momentum is conserved. What we concluded from the conservation of momentum? We concluded one thing, that for every action or to which extent we are applying the force on it, to that extent we are getting that force back. Okay. So what is that? The momentum is conserved. That means what, ma? For every action, the reaction will be equal and it will be in the opposite direction. This is what the law of conservation of momentum says. Okay, ma? Now we are moving to have the question time. Are you ready, Kirna? Okay. The first question is, according to third law of motion, action and reaction acts on same options are the same object, different objects in opposite direction, different objects in same direction. Okay. Different objects in same direction or in opposite direction, or same objects in same direction or in opposite direction. Okay. You have to find the answer. Okay. Second one. Inertia of the objects tend to cause the object to dash. Inertia. Because of inertia, what is the inertia doing? It tends to cause the object to resist. To resist what? I think you will find the answer by yourself. Okay. Rocket. Third question is, rocket works on the principle of conservation of dash. Conservation of dash. Okay. Now the question time is over and it's the time for me to say bye to you, and I wish you to write the answers in the comment box.